Okay, let's talk about fundamental data types for a second. The most fundamental data types in computers and in coding include integers, which are whole numbers, floating points, which are decimal numbers, chars, which are single characters, strings, which are a string of characters, a bunch of characters together, and booleans, which are true and false statements. But rather than just talk about them, let's see what those actually look like in code. So I'm going to go to Repellent. This is an IDE that lets you compile code so that you can see what you're coding. So if I were to hit run on this code that is over here, this is the language called Java, over here you'll see the words hello world, because that's what it says to do right here, right? This hello world inside of here, that is a string, right? That is a string data type that is used to store more than one character, right? This H by itself is a single character. This E by itself is a single character. But when they're all together, that is called a string. Another way you could have done this, if I move down in the code, is I can create a string called hi, and I can set this equal to hello world right here, and then I could just print system.out.print the variable called hi, because this data type now, this string data type is called hi, and it has hello world in it. So if I hit run again, I should get hello world over here on the console. There it is, right? So you can use this for a number of reasons, right? Like if you're creating something where you need to store somebody's name, you can have them put in their name over here. We'll say Mario, right? But there's other fundamental data types, right? The integer is one, for example, a whole number. So integer, int for short, we can store somebody's age, right? Let's say Mario is, maybe he's in his 40s, right? Semicolons end every statement in Java. That's why you see me doing that. But int is going to be called age, and it's storing a value of 42. So what I'll do now is I'll print out our name, right here, name, and age, and I'll hit run on that. As we go through this and run these codes, I'll continue to add more variables. Right here you have Mario 42. Other variables can be things like floats, so you can see the difference of a float. Let's do Mario's weight. Mario's pretty small, right? So let's say Mario is something in the like 150-pound range, right? If I print this weight, what you're gonna see is the difference between weight and int is that the weight is going to be stored as a decimal point. Right? You see the decimal point there? And in Java, we might even want to, I'm going to comment this out real quick. In Java, it's probably better to use a double for decimals, so we can do something very specific like 150.85 pounds. Right? So I'm going to, this doesn't count anymore. I'll just use this so I can be more accurate. Okay, so this is kind of like representing decimals. All right, so that's our ints. Was age. We use the floating point. I changed it to a double. That's easier to use in Java. A char, a string. We used the string already, so we need to use a char and a boolean. So a char is just a single character, right? Like I said before, this M is a single character. His grade on his run. Did he get an A run, a B run? Did he do good? Or did he get an F? Chars have a single quote and a single character. So his grade on one of his run-throughs was an F. So if I go over here and print grade, you'll see that the single character comes up. Now if I go into here, there it is. If I go into here and I put two characters, like let's say F minus, I'll do more than two characters, you're going to see an error because a char, a single char, is a single character. It could be a number, it could be a symbol, but it has to be a single character. If you want to do multiple characters, you have to do a string. Strings have double quotes, right? Characters have single quotes. You could do a number here, but you just want to be careful with that, because numbers that are stored in char, you can't do math on later. And if you're really trying to code something, this would kind of be useless to you, depending on if you just want to show somebody something or if you want to do math to it, right? Like I could do 42 plus 1 here because this is an int, but I can't do 5 plus 1 because this is a character and it's not going to view it as a real number. Okay, so let me get rid of this, and then we'll do our last type, which is a Boolean. Boolean is really easy to remember because it's one of two answers. It's either true or it's false. So you know when Mario gets the fire plant and he can start throwing fire, right? We want to know, does he have the fire plant or not? Boolean has fire. Does he have firepower? You could even add the word power. Right, so has firepower equals true, and then I'll add the print line and run it, and it's going to give me all my fundamental data types. Strings, ints, decimal places, I use the double, could be used to float. Chars, single characters, right? A lot of times we think of these as letters. And Booleans, true or false statements. Okay? Okay? So all these things use a certain amount of data, starting with Boolean being the smallest. Strings have no limitations. Strings have no limitations, but all these primitive type variables do. All right, there's your fundamental data types.